Hi guys, welcome back. So I want to start with an easier example using the chain rule, and then once we understand simpler ones, then we're also going to look at more challenging ones. Guys, if I look at this function right here, you can see that there is a cubic function inside the parentheses and then it is raised to the power 5. Obviously, we can see that it is not just one function, it's a combination of some functions. It could be one, two, or more, okay? So in order to find the derivative of this function, obviously one way would be to write it out 5 times and then use the product rule. But guys, that is going to be way too much like time consuming and a lot of work. One has to do that if one does not have any other methods. But guys, we already figured out the easier and quicker method of dealing with composition functions or bigger functions, and that method is called the chain rule. So guys, using the chain rule, we can evaluate the derivative of this function. In this video, guys, I'm going to show you 2 methods of doing it, and then it's up to you which method you want to use. Later, guys, in my videos, I'm going to only use the method that I like or I prefer and that I have been using forever. But guys, if you like the other one or you're used to using the other one, that's fine. There's nothing wrong with any of those methods. Both methods are valid and both methods are going to give you the final answer. Guys, again, I do not push anybody to prefer one over the other. It is up to the student and you are liking which method you like. So for this one, let us start with the method which involves the derivative notation dy over dx sort of notation. That is the one that I don't usually use, but guys, I'm going to show you for this particular example both methods. So let us say for that method to work, what we start with is we start with let u equals to, so we start more like in terms of a substitution kind of a thing. So u equals to whatever is inside the parentheses, right, without the exponents. That's what we start with as the substitution. And I think that is what we usually do with any sort of substitution in general here, even with the integrals. So this is plus x minus 1. That is my first substitution. And guys, obviously my other thing what I have to write is what would be y now in terms of u. So y in terms of u would be, since this is u, so it would be u to the power 5. So all I have to start with is this substitution, and then I have to write, once I have u, and then I have to write y in terms of u. Guys, once I have this, then I know what we want. We want to find the derivative of y with respect to x. That is what we actually want to evaluate, right? We don't have a direct way of doing it, and we are trying to use the chain rule. So guys, using the chain rule, we know this equals to dy over du, right? And it's up to you guys. I'm using u as my variable. You can use any variable you like. And then times, again, du over dx. And we understand kind of behind the scenes, these two are just canceling out, and then we get dy over dx. So that's like a quick and easy way of seeing or kind of understanding this whole thing. So guys, based on this, what we are trying to do is we're on the right hand side, we have to evaluate 2 derivatives and multiply them. That is the whole idea of the chain rule if we use the dy over dx notation. So dy over du, guys, not too difficult, just use the power rule. So it's just going to be 5u to the power 4 using the power rule, and then I have to multiply this by what? I have to multiply by the derivative of u. Guys, derivative of u, again 3 terms, but we can use the power rule, and I'm going to put that in the parentheses. In the parentheses, it's going to be 3x squared plus 1, and derivative of 1 is 0. Don't have to worry about it. Guys, we're almost done, but we just have to do one last thing, which is, since we want everything is in terms of the x and we want to find the derivative with respect to x, our final answer should also be in terms of x, which we can easily write by just substituting this u back here with x cubed plus x minus 1 raised to the power 4, and then I just have to multiply by 3x squared plus 1. Guys, you don't have to really simplify from here. You just leave it like this, and this is the derivative of this function y with respect to x using the dy over dx method of using still the chain rule. Guys, this is one of the ways of doing it. The other way, again, is kind of similar to this, but it's slightly done in a different way. And that's how I prefer doing things. So guys, I treat this whole thing as a big X, okay? And what would I do again, I'm still using the chain rule. Using the chain rule, first I have to find the derivative of this whole thing as such. So what is the derivative of this whole x to the power 5? It is still 5 x to the power 4, but x is not just x here, it is these 3 terms, x cubed plus x minus 1 and to the power 4, because using the power rule n minus 1, 5 minus 1 is 4. all I have to do is, instead of just writing an x here, I have to write whatever terms I have. In this case, I have x cubed plus x minus 1, so I'm going to write that. If I have something different, then I'm going to write that terms, okay? And then we know that we have to multiply this. That is the only that is the only different thing here compared to any of the other rules or any of the other methods that we have learned so far. You have to multiply by the derivative of the inner. So in this case, the inner is what is inside the parentheses. So you just have to multiply by the derivative of these three terms, which is going to be, again, we're going to put that in parentheses because this is more than one term. So it's going to be 3x squared, and then derivative of x is 1. So guys, I'm done finding the derivative of this function in one step. Here I had to write few steps, more than few actually, to finally get the final answer. But this is the same. So guys, it's up to you. If this whole notation thing makes more sense to you guys, so then use this. Otherwise, just use this simple and straightforward method of doing it. Guys, if I have more than two functions here, then I will keep on multiplying by the derivative of the inner. But this first piece is not going to change. You're still going to treat that as like an x to the power n type of a thing, and then use the power rule on that one. Okay, so guys, this was an easy example, but I wanted to start with something simpler. And now in my second example, I'm going to bring in little more more complicated or complex functions, and we will learn how to find the derivative of those functions using the chain rule. Till then, guys, take care. I will see you.